Okay, hello everyone. So we are live. This is my normal Tuesday, Thursday study session. And we're running into the same, I guess, issue as before, where we are working through this Intro to Statistical Learning book. Oh, okay, so let me rewind. My name's Aaron. It's nice to see all of you. And I do these Tuesday, Thursday study sessions to kind of force myself to study and review some stuff. And currently, I'm trying to go through the Intro to Statistical Learning textbook, just as a review of kind of a lot of statistical slash machine learning theory. And one of the things that I wanted to do that I thought would be fairly interesting is that there's a lot of labs written in this book, and they're actually written for R. So the four co-authors of the book apparently only use R, and on their book website, by the way, website has the book for free, so you don't have to buy it. It is a PDF, and it's great. Like, how can you argue with free? And it's such a good resource. The only problem is that one, they don't seem to have an actual GitHub, and so you download all the notebooks and stuff, and like it's just there. And two, they have seemingly no intention to convert this over to Python, which, to be fair, if they don't have to use Python, they're not obligated to. But it is a little annoying. Like, I don't really want to learn R just to go through this statistical book. I already know a little bit from work and all that kind of stuff, but in general, I just prefer to stay with Python. So it's been kind of like a side project that I wanted to do, which was to essentially just go through this textbook, convert everything over, and then just contact them and say, look, do you just want this? So yeah, basically where we are right now and where we left off from last night, which was quite late, we actually, I believe it's here because I scrolled down, kind of musing on this like set seed and the creation of a vector of all random normal variates or variables. It was very confusing. Like by default, these are supposed to be centered, like the mean is 0, the variance is 1. And I'm finding that in Python, it does seem to do that, but in R, it doesn't do that. And I kind of wonder if like maybe if I start this over, just like there's an idea of, it's intended to be mean of 0 and a standard deviation of 1, but maybe it doesn't actually hit that number. And I wonder if this this execution R is a little bit more flexible, and I don't know if like Python, this scipy.stats is like very strict on like, no, it will hit a mean of 0 and a standard deviation of 1. So I'm just gonna, I've already opened terminal, started my virtual environment, and I have all my stuff set up. So what I'm gonna do is actually go through Visual Studio Code here on the right side of the screen. Without having a second monitor, it's kind of hard to tell where everything is without opening OBS again. So I'm gonna hit this this execute above cells. I know it's gonna error out on the part where I ask for help for describing the del function. Oh no, I commented it out. Good, because that just breaks it. So I kind of wonder if, oh, this should be, maybe I'll actually just convert this to Markdown. Oh boy. If I can. Oop. But yeah, I'll try to pop in a chat. As you can probably figure out, it's a little bit hard for me to see the chat window while I'm actually streaming. So if you have any questions, just put them in there. I'll try to get to them when I can. Okay, cool. Looks like the random seed is working. Okay, so one of the days I had last night, actually like right after I signed off from stream, was I kind of wonder if I can just save this particular thing as a vector and then take the mean and all that kind of stuff. Because I'm not sure if this is maybe just making another one, even though this is supposed to lock in a particular thing. So let's say test y equals... yeah, so test, and then we'll just say test y.type. Of course it's not. Oh, right. NumPy array. Okay. Okay, well, there goes my theory, because if it's a NumPy array. Okay, cool. So it's not. So yeah, this is actually something that I'm not necessarily a huge fan of. So what I'm going to do is I'm actually going to set this as a y scipy r is vec equals this. And then I actually need to close the parens. And then we're going to print this. And then from that, instead of using this, because this is actually, I think, just making a brand new thing, which is a little unfortunate, we're just going to use the NumPy functions essentially. So I'll just say it seems that creating a normal random variable with RVS doesn't guarantee that it is locked when you want to use the stats functions to find mean, variance, skewness, and kurtosis. So you will have to save that vector and then seemingly perform NumPy operations on it. Okay. So, and that actually, I wonder if that will help a little bit with this random seed stuff, because this is now stored. So yeah, okay. So we are going to comment those out, and then we're going to say print. We don't need this anymore, or this. We want to print the mean of this. And then print dot variance. I don't know if that is going to work. Yeah. So we need to look up the documentation to find variance in NumPy. Okay, cool. So it's just var dot var. And then print. I don't know if we can get skew. Let's see, skew. I don't think that's going to be possible. So that moment is not going to be there. And then I have a feeling we can't also find kurtosis. Yeah, okay. So let's say NumPy does not have methods to calculate skewness or kurtosis. And for, I mean, this is a normal distribution, so it shouldn't have those things. And I think before it actually said 0, so yeah. But it's nice that like those are available in, I guess, the stats package. It's just kind of weird that like I can't recall, like I can't do this function on this vector, right? So okay, let's see if this works. Yeah, that's okay. So let's actually see if we can. What happens if, like, I'm pretty sure this is just a, because we already showed that it's just a NumPy array. Like if we do stats moments typing those out. So if we save this, like I am fairly certain this is not going to work. Yeah, of course not. Okay, so let's just move on to the next section. So we've got, all right, now we're in graphics. So we want to actually import Matplotlib, and I remember talking about this yesterday or last night. So we're going to do Shift Enter there, and it is imported successfully. So we are going to, well, let's keep using the SciPy version. So we are going to say, oops. We are going to do this where it's actually not what I wanted. Okay, so insert this here. So we're doing, we want to create, we don't need this anymore. So we're going to say x plot equals xplot1 equals stats.norm. And then let's say yplot1, because I saw that there's a lot more to this that we're going to do. If I actually, I don't think we need the random seed for this one. That's okay. It doesn't particularly matter. So we'll do xplot1. Oh, plot1 rs vector equals xplot1, and we'll say the loc should be 0, the scale should be 1, the size should be 100, and then we're actually not going to use random state. And we will take that, put that there. And then similarly, we just copy this, and we will do this again for y. So be yplot1, yplot1, and then we want to plot this vector and this vector, and put a semicolon here, and it shouldn't make that like weird thing after. And yeah, cool. So it will be different each time, which is maybe not a huge deal. So now we often want to save the output of an rplot. The command we would use to do this depends on the file type we would like to create. For instance, to create a PDF, we use the PDF function. I really don't like that that's called PDF because they have probability density functions, and that's also called PDF in R. That seems like kind of a mistake, but whatever. So we actually need the Matplotlib documentation. Save plot. Cool, save fig. In this particular instance, we have to specify the file path. Okay, so let's see. Yep, that's okay. So we want to what we'll actually do is so if we were to make a new plot, insert markdown cell above, if we wanted to export the plot as a file. We can do that by using matplot, oops, lib, whoop, matplotlib.pyplot.savefig. And then we can link the documentation here. Oh, excuse me. So let's use the previous thing. Let's add a code cell above. So in their examples, they are going to take that same plot. I'm just going to take the same plot. So we'll do file path. Let's say PDF file path equals, we are a notebook, so we want to go up one. I have a file tree explorer right here. So we're going to go up one directory, and this is going to be a relative file path, and then into data, and then we want to say first plot demo. And what do we want to make it? We can do this behavior is unset when this is unset and if is documented. The behavior when this is unset is documented under file name. Okay. If format is set, it determines the output format and the file is saved as fname. Note that fname is used verbatim. There's no attempt to make the extension. If any of fname match format and no extension is appended. Format is not set, then that format is inferred from the extension of fname if there is one. Okay, so what we want to do is first plot demo, and then we are going to do plt.savefig pdf fp, or let's say fname. Fname equals, and then this is going to be format equals, let's say PDF. What else are they looking for? And then they changed the X and Y and call to green. And then they told it that it was done. Guess we can do that. Not sure what the call is. I guess color, X, Y, and color, but there's so many different colors here. Okay, well, let's give this a try. Cool. And we look at data. Look, there it is. With no extension. That's cool. Nicely done. Why won't it save as a PDF? Let's do PNG. Maybe there's like some open source thing that it's relying on the back end to make the PDF. And nope. Wow, cool. Thanks, Matplotlib. Why don't we just do this and then just get rid of the format. Zero axes. What? Reveal and Explorer. that didn't work. That's very weird. I wonder why. Does it have to be? Man, that's really weird. I wonder if it has to be in the same cell. So it kind of looks like it has to be in the same cell. Yep. Yeah. Okay. We're learning a lot of stuff. That's okay. Okay, so let's move on to the next thing. The function dev-off indicates to R. Okay, the function sequence can be used to create a sequence of numbers. So let's insert a markdown cell above. The numpy function arange can be used to create a sequence of numbers. Let's see, numpy.arange 1 through 11 will make a vector. Well, okay, let's follow their same naming convention. B, make a vector of integers between A and B, including A but excluding B. Shift enter, look, it works. So now we will create some more sophisticated plots. The contour function produces a contour plot in addition to, in order to represent three-dimensional data. Okay, so we need to figure out how to do Matplotlib contour. Okay, so that was easy. What we're gonna do is follow their same things. So insert code cell above the oh, this should be markdown. Matplotlib function contour. Can be used to create contour plots. In order to represent three-dimensional data. And we want to actually put the documentation in. It requires, let's see, the following parameters. So be contour contour x, y, comma, and z. Where x and y must both be 2D with the same shape as z, or they must both be 1D such that len x equals n is the number of columns in Z, and len y equals m is the number of rows of Z. They must also be ordered monotonically. I didn't know that. Monotonically. Okay, so what we're going to do now, we're going to shift enter here, and what we're going to do is with the plot functions, there are many other inputs that can be used to fine-tune the output of the contour function. Learn more about these, take a look at the help file typed by generating contour. So we can actually do similar, so it would be help plt.contour, I believe is the command. So if we do that, yep, cool. And what we're going to do is we're actually going to store, so they made, what on earth did they do? Okay, so they did a interesting collection. So they took the A range. Okay, yeah. So what they did is they kept this X, I wish they just rewrote it because it's all different cells, and then Y equals that as well. And then we have F, they made F, so let's say that's Z equals outer. What is the R outer function? The product of the arrays X and Y. Where, okay. Function to use on the outer products. Okay. So the function they decided to use was cosine y 1 plus x squared. So we can try to do that here. It would be, what is it, cos y divided by 1 plus, oh, np. Oh, actually, I just did it right below. Okay. I don't know why they did F. So let's see what happens here. Too many values to unpack. So instead of copying that over, I've seen that work sometimes where it's like you have two variables equal the same thing or the same function. I'm not sure why it didn't work here. That worked fine. Maybe Numpy doesn't allow you to do the function twice and store two different variables. So after that, we are going to do plt.contour and then be x, y, z, right? According to what I wrote up here. Yeah. So let's put a semicolon so it gets rid of the ugly thing that gets outputted. No contour levels found within the data range. Awesome. Now, why didn't that work? If I set what happens if I do this. Cool. Cool. Okay, so I messed this up. X and Y are, I should have read that bit. X and Y are optional. I guess when you feed it in, oh, because it's a array, it knows the dimensions already. So if you can either feed it, I guess, X and Y, or you can do, let's try to do this, Z. Okay. Input Z must at least be a 2x2 shaped array, but it has shape, but is one dimensional. Okay. Oh, okay. This is definitely not an array. I think maybe I can do, oh, that's why I had that. I needed to actually reshape this because it was two vectors. So if we do this, oh, that didn't work. So that worked okay for fixing that part. But for this part, what is the error? Setting an array element with a sequence. The requested array has an inhomogeneous shape after 2 dimensions. Detected shape was 210 and an inhomogeneous part. Okay, so before all I did was do an x.reshape. So I can just, I guess, do the same thing. Okay. And does this work still? Yes, that one still works. That's interesting. So let's go back up here and do x.shape. Maybe just put them all in one cell. Stir. Copy this. Put this here. Do y. Shape. Do this. And now we have z. And interesting. So, what happens if we just print y? That's why, because it's making. Oh, actually, that makes sense. Because if without these inner brackets on things, it's going to be taken as just a list, and that's what x is. Let's see. That is odd. Let me see. How do we fix this? So setting an array. Oh, there we go. I'm looking at this Stack Overflow discussion, kind of wondering how I think I got it. I think if I do this still, but then, oops. I think if I do that, maybe that will fix it. Let's find out. Okay. I know what this problem is, this plot, because it's not actually plotting the function. So that's why these look different, is because like I have explicitly given converted the x and y values into a function here, and they are. I forgot that this contour plot is kind of not really doing what I think it's supposed to be doing. So I guess these I don't think these functions entirely line up, because this R function actually requires 3, but the Matplotlib function does not. So I actually kind of wonder what will happen if I do like this. If I put Z here, yeah, I was like, that's not gonna work. Okay, so that's really interesting. Now, if I were to a vector of the x values, a vector of the y values, so those are fine, those match up. The matrix whose elements correspond to the z value for each pair of xy coordinates. That's really weird. I'll just keep going. As with the plot function, there are many. Okay. The image function works the same way as contour, except that it produces a color-coded plot whose colors depend on the z value. This is known as a heat map, and is sometimes used to plot temperature and weather forecasts. Alternatively, persp can be used to create a three-dimensional plot. Arguments theta and phi control the angles at which the plot is viewed. So let's get rid of that. Man, that's weird. Why did I go into using pi? Because they're not. Oh, okay. I may have skipped over that part. Okay, so we will. So that is technically correct, but what they actually did was they plotted this. So that is also correct and honestly better, because the other thing is like really ugly. It doesn't entirely make any sense. I was like, what a weird thing to plot to test your thing. Why not actually do that? Like that, this is way more informative as to what's going on. Okay, so we actually also want to try a heat map function. And then let me pop into OBS for a second. Okay, cool. How can we do heat maps? So let's try, what is the R equivalent for image? Matplotlib R image. Matplotlib, let's say heat map. Okay, is there actually a penalty to subplots? We've got an array, set p, I don't think that's it. Yeah, this isn't quite, I think, what I was trying to figure out. It works the same way as contour, colors depend on the z value, but you can actually just do that with, I think, levels and stuff. All right, let's just move on. So change cell to markdown, and now we've got, this is, I think, 3 in. Yeah. So 3 in, and it's 2.3.3 indexing data. Okay, we often wish to examine part of a set of data. Suppose our data is stored in the matrix A, where we have a 4x4 matrix, and it is going to be np.array, and is going to be from 1 to 16. Those are the elements. So if we wanted to do that with Numpy, we can do, where is it? Here. Let's actually make this a neater, follow the same convention, like essentially using a function. Create numpy array of size. Array creation. So do we have to specify every element in here? So we have a 2D function. Vandermond, general ND functions. I think I actually have to like specify it. That is not great. There's probably a function I can use where it's like, so we can do np dot maybe ones, and times like linspace maybe. Let's see. Okay, still looking at numpy.ones. Okay. So we can do np.ones, and it would be the shape before, and we can multiply times num for num in range, be 117. Is that going to work? Oh, that's not. I don't think that's it. Yeah, I was like, that's not valid syntax. Numpy create array with increasing numbers. There we go. How to fill a 2D array with increasing numbers. I don't want to add 10 to each one, but man, that is definitely less elegant than R. This is like, instead of creating a matrix, it says to actually just create range. So it'd be, we're going all the way up to 16. Oops. And we want to reshape. It's not hard to create a one-dimensional NumPy array with increasing numbers. Create 2D array, sequential integers. Just use reshape on a normal arange call, which will simply reshape your array without changing the data. 16, so then what we want to do is 4. So we print A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So let's say 117. Okay. Yeah, that's what we wanted. So obviously, this is obviously way less elegant than the R way, as you can tell. But okay, learned something today. So if we want to index this, let's insert code cell above. So if we do sorry, I'm also watching some Twitch streamers right now, just having it on the side. So what I've got on the side to kind of, I'm lurking, I guess, to show support is there's a developer, Juicebox Hero, and then also a VTuber named Luxshi. Luxshi, I saw her first stream, not first, my first stream of hers yesterday. She seems very chill. Let me make sure I got her pronouns correct. I think so. And then Juicebox Hero is a developer. Also seems cool. Working on some stuff right now. And then I'm actually debating watching. There's Learn with Leon, who is, I believe, teaching some software development. So I may try to watch that later. Yeah. So now we want to try to index this data. Then let's do Markdown actually, and we can actually just move this. Then typing, if we do A to 3, is it going to give us the same thing? Why is it giving us, man, okay. I wonder if I do 4 minus 4. They index rows and stuff differently. Dot T. Yeah, okay, so I will comment on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 150, 16. So if we, there's also yeah, okay. Let's see. I'll also put a comment in here. So keep in mind Python slash numpy indexes. Starts. This is an off by one error. Indices start at 0, and also pick. And also chooses, I believe, row first, then column. Chooses to fill rows, then column first. So this will select the element corresponding to the second row and the third column. Yeah. The first number after the open bracket symbol always refers to the row, and the second number, okay, that is actually still valid here. Change cell to markdown. This calls the element in the second row and third column. The first number after the open bracket symbol is the row, and the second number is the column. So we can also select multiple rows and columns at a time by providing vectors as indices. Let's see. Change that to code. So if we did a 0. So they picked 0, 2. So this picked the first row and the third row. So this picked the first and third row. But they were actually looking for the first row, the second. Okay, so then this would be 1, 3. Kind of worked. It's just slightly different. We've now only got 2 elements instead of their 4. So why isn't this the same? Array indexing. Numpy array indexing. Indexing routines. Okay. Do take. So we might have to do np.take. And then this is what, 1, 2? Oops, missing that. What? What? How did that happen? Indices is not one-dimensional. The output also has these dimensions. Okay, so we should have gotten we wanted 5, 13, and 7, 15. So what we ended up getting was 1, 1, 5, 9. Okay. Oh, this should be 3. We got 1, 9, 5, 13. So we only took, that's weird. We only took the first row and took them in different orders. And we should have gotten 5, 17. Why did it do that? So Geeks for Geeks is driving me crazy. I used to really like it because they had like helpful tutorials or like helpful quick things, kind of like this W3 Schools does. But now it's like if you click on Geeks for Geeks, like you like a second after it loads, it asks you to log in, and it's like, why? It's like, I don't know. I think it's just like crazy annoying because it's just like, why did you make this change? Like, I obviously do not want to use this site anymore. Okay, so we have access the. So this is not exactly this thing I wanted. Because this is going to a particular location. So it's a second element on the first row. But I actually want the sub-array. So numpy extract sub-array. So this would be given A. We can try to do, what was the thing we're trying to pull out? The first row, second column. So it'd be 0, oops, 0, and then the second row, so 1, and second column, third. Dang. Just do this. Oh, come on. Okay, so this is everything in the first, everything in the first column. Okay, so let's go over this syntax. So based off of what it's returning, it's saying grab everything, but from the second column. So we actually just want, where is it? We only want 5, 7 from the first column. So that would be 0, 1, 0, 2 from the first column. And then we also want, so what happens if I put this in here and then kind of do the same thing all over again? But instead we have, we want 7. This would be the third row. 15. Oh, I don't think this actually will give. I'm not gonna lie, I super don't know how useful this is, because I've never had to do this before, or ever. Like, doing these sub-indexing is like kind of a nightmare, just because when I started using pandas data frames, like, I don't index this way. You just do it by the column and then like the particular values you're looking for. So like, to try to do this manually, I think would just drive people crazy. And just, it's kind of like how I'm being driven a little bit crazy right now. So I don't entirely see the value of learning how to do this, but I'm just kind of like working through the motions to see if I can. And one thing I'm noticing right now is as I'm doing this, it's still inverting it. So I feel like I will have to pull out the data and then invert it again, which doesn't, to me, is like a little odd. I don't know why I would do that, but we can try. Yeah, of course, that's not going to work. So if we did, such like a niche use case. So what if we did this? Why don't we just copy the thing that is happening in there? What is that giving us? So it's everything except for the very first column. Because it's saying, give me everything, give me all rows from the second column onward. So in this case, what we actually want is we want the first and third we want 0, 2, and this would be 13, 15. So it's from the last column. Sorry, it's from the, yeah, so it's from the second column and the fourth column. What happens if we do this? Yeah, I'm not. I was like, that's not gonna work. Oh my god, I really feel like I'm honestly getting like really frustrated with this because I seriously think this current exercise is a huge waste of time to me. Like how long have we been spending on it? Wow, we're an hour into this stream, and I've gone like half a page. I am just gonna put in here. I don't think this is worth looking at. Not sure if mastering this syntax of extracting subarrays from an array is worth the time investment. So I am electing to skip most of this session after burning a lot of time in it. Like some of this stuff I think is useful, like trying to, let me see, how to skip numpy extract subarray skipping elements. How to skip, freaking Geeks for Geeks, and the pop-up comes up once oh, it didn't do it. Okay, cool. Yeah, so we have a start, an end, and a step. So this is a one-dimensional array, so that's actually really easy. Efficient way to slice a 2D array and skip indices. Step, skip, index, so a range. Mod, skip plus step, less than step. I am not going to do that. Yeah, sorry, this is going to be like an incomplete tutorial or walkthrough. I just don't think this is like super worth the time. I don't know why they really wanted to do this. Yeah, I mean, like some of this stuff is actually kind of like makes sense. It's like if you want to extract everything in every row in the first and second columns, you could do what did I just put? 0, 1. It's just this like skip indexing is odd. It looks like it's not as easy to do as in R. Yeah, okay. So if we wanted to do that, because I'd skipped one thing, so if we wanted to do the first and second columns, first and second columns, but all rows, or first and second rows in all columns, then that part's super easy. Yeah. And then if we wanted to do the first row, I don't know what this is. We can try it. Minus. And then they picked, let's see, it would be 1, 2. Yeah, that doesn't, I don't think that makes any sense. Oops. No, that's okay. That part is not okay. Right? No. I'm not doing that. I'm not going to try to figure that out. But then if we want to do just the dimensions, we can just a.shape. So that's really easy. Okay, so Man, sorry. I feel like that was honestly just like not a good use of time trying to figure out that weird sub-indexing. So loading data. For most analyses, the first step involves importing a dataset into R. The read.table function is one of the primary ways to do this. The help file contains details on how to use this function. We can use the function write.table to export data. Before attempting to load a dataset, we must make sure that R knows to search for the data in the proper directory. For example, on a Windows system, one could select the directory using change dir option under the file menu. The details of this depending on the operating system that's being used, so we do not give further details here. So this is actually part of why I didn't think this previous section was totally worth the time. We are trying to load data into Python. So I think we can try to load Numpy load CSV or read CSV. I don't really think that's good because let me see. Yeah, you should definitely be using pandas. Mostly because this is actually, I think, like pretty clever. Like this read.table is just a function built into the, I guess, R. But for reading a data table in, you wouldn't even use NumPy. You'd honestly use pandas because you want to record into a data frame. Otherwise, like if you saw in that previous Stack Overflow, it's like, oh, well, you can just do this, but it's really complicated. So we're not even plotting anymore, but I'll leave that open. Not looking at the seed. That might be useful later. We should be using the pandas library to import data into a data frame, which is paralleled with the R tables. We can use pandas.read CSV to do this, and export the data as pandas. I've only ever done pandas write. Yeah. Data frame to CSV. Like, yeah, I guess it's a slight difference. Like, you would do the pd.csv, excuse me, but then you would use your actual data frame and then .csv or .to CSV instead of calling pandas itself. So let's import the auto dataset and store it in a data frame. Import pandas as PD. So it'd be, that should be code. Convert to code. And this should also be code. So we have PD be auto equals, let's actually specify the file name. Yeah, okay, so auto fp equals, this is relative file path. We go up one in the directory, go into data, and then we do auto.csv. Oops. And then we would do, we don't have to specify into a variable, but I think it just like looks neater because the next step is to just say pd.read CSV, and then we can do AutoFP. Instead of having like one long line of read CSV, especially once some data sets, once you're maybe more familiar with them, or if you want to do some like pre-processing before even opening the data as much. Like there's all of these things that you can specify in the function. So it's just like, you might as well just like try to keep it simple. And yeah, plus you can change the file path in here without it like breaking the next step. So we can do let's do head. And that would show the top 5 as well as the headers. Actually, I'll add a little comment in here. The above split the cell, and then whoop, and we'll insert markdown above. Oops, change that to markdown. The head function for a data frame can display the headers and n rows of the data frame. N defaults to 5. Okay. Note that we use .csv is simply a text file, which you could alternatively open your computer using standard text editor. It's often a good idea to view a dataset using a text editor or other software such as Excel before loading into R. Interesting. This particular dataset has not been loaded correctly. Actually, I guess I should write all this stuff down. Auto.csv is simply a comma separated values file. You can open it in a variety of other programs. And it may be a good idea to read it in something besides pandas first. This particular data set has not been loaded correctly because R has assumed that the variable names are part of the data and so has included them in the first row. This has not been a problem with pandas. Pandas by default assumes the first row is a header row. So it has loaded here correctly. So actually, in contrast to the R lab, the first row is loaded correctly, although there is still missing data. So what we can do is auto equals, oh, just code. Let's see. Why do I keep having to look this up? Pandas display all null values. Is NA dot any access equals 1. Oh, okay. Well, contrary to the R lab, pandas by default assumes the first row is a hetero. Pandas show show any rows with specific value. Oh, this is not going to be as elegant. So, because we are using the CSV, there is no specific marker for missing data, like in the demo. We can do a search for the string question mark, but the code is not as elegant as demonstrated. So it's not as simple as like, I thought it would just be like, oh, this is an, excuse me, this is a null value. So just return back the null value. But as you can see, there are no null values in this data set, probably because the question mark is not there. So, I mean, we can go through the columns and do the search for it that way. Like, so if we did name equals question mark, like that's not in there. I mean, the easiest I don't really want to do this, but like the easiest way to go through all of them is to just say like for call in auto.columns, make this a stupid for loop, and then it would be auto call equals, just to print, close this parentheses. Print call. Let's make this if dot shape greater than 0. let's do. Oh. Oh, no, that is my fault. Okay, so the problem is I knew this was going to happen because we get a two-dimensional data frame. So let's do name again. Oh, that's not what I wanted. Okay, so if we want the number of rows to be greater than 0. Okay, cool. So in horsepower, we've got missing horsepower. I would not recommend doing this if you've got a lot of data because this for loop, or a lot of columns because this for loop will take a while. But at least now we know that, like, oh, there's just 9 rows. Print. Then we also want to print. There are 5 rows. 5 rows that are missing data. Okay, cool. So, and then similarly, basically just use that trick. So if we do auto.shape, we can get the shape of the how big the data frame is. Let's see. So we want to insert a markdown cell above, and we're going to say we like with Numpy, we can use the shape function attribute to tell us how many observations and columns there are in the data. We can use data frame indexing to drop the rows with this missing value. So let's say cleaned equals, now that we know it's in horsepower, so it'd be auto horsepower. This is like it's data manipulation, so I guess it's kind of data cleaning. So it's kind of data science. It's just that this is a little tedious and quite brittle. So when we don't want it to equal this unknown value, that should give us cleaned all of the records that are fine. So we just dropped 5 records. Yeah. So if we want to see, we can use the columns attribute to give us the names of the columns. So we cleaned columns. Oh, dang it. Every single time, I bet. Change cell to code. Yeah. I wonder if you can use that as a function. You can't. Okay. I mean, you can do toList, so it's a little bit cleaner. Yeah. Maybe actually, I'll just make that a separate cell. Insert code cell above. And actually, I should have just done this. You can use that in combination with the toList function to output a Python list that prints a little cleaner but with less detail. So yeah, I mean the difference is like this is considered an index, so that, and it tells you what type of data it is. Obviously with these being column headers, you're kind of expecting them to be strings, so they would be objects. The data type would be object. But if you just want the names, just like they're doing in the lab, then you can do like clean.columns to list. Yeah, so let's change this cell to markdown, and then header 3, additional, graphical and numerical summaries. We can use the plot function to produce scatter plots of the quantitative variables. However, simply typing the variable names will produce an error message because R does not know how to look in the auto dataset for these variables. That's interesting. So Pandas has like a wrapper around Matplotlib, so you should be able to like let's say cleaned dot plot. Let's make this bigger. Fig size, let's say 2015. Yeah. So this may only work with cleaned. And 1, 2, 3, 4, 5, 6, 7. So there's 7 columns. So it obviously didn't factor in name because it's not numerical, so it can't do anything with that. What else did it drop? MG cylinders, displacement. Oh, horsepower. Why isn't horsepower? I mean, we can convert cleaned horsepower dot describe. That's why. Okay, so because those question marks were in there, Pandas converted the entire column to strings. So let's actually change this to markdown. Because, let's also add a little note, markdown cell above. Horsepower was not plotted even though it is numerical. Why? Because upon import, Pandas converted all values of in the horsepower column into objects, here strings, because of the missing data, which were all in question mark form. So we can convert the cleaned horsepower column back to a numerical value if we want. Okay. So to refer to a variable, we must first type the data set, and actually, wait, we haven't had this for like an hour and 15 minutes. Oh my gosh, an hour and 36? Okay. Oh wow, it's already 6? Okay. I was gonna take a break. Let me see. I could still take a break. I kind of want to be completely honest, but we're almost through here, so maybe I'll just like finish this 2.3.5 and then ooh, there's exercises. Okay, so that can actually be like real studying. And then there's an applied section. Okay, cool. So this is actually, yeah. Let's just power through. um, oh my gosh, I need chapstick. Uh, let's see. Okay, so what we want to do is uh, so to oops. To refer to a variable, we must type the data frame and column name, column/variable name inside either square brackets, oops, or with loc function, or with dot name. Here the cylinders variable. Let's put this in code. Cylinders variable is stored as a numeric type, but it may be more useful to treat it as a qualitative or categorical variable. We can use the as type function to convert variable into different data types. So that would be pandas as type. I forget. I always kind of forget if there's an underscore, and there's not. Okay, so let's shift enter here, and then add code here. So we want help pd.as.df as type. So what we want to do is cleaned where did it go? Oh yeah, okay. Cleaned, so we want to do cylinders equals cleaned cylinders dot as type, and I believe we can just make this we actually need a list of, there is documentation for this. I wish that they made it easier to figure out what data types pandas supported. Like, I honestly think this should just be a link, and it never is. And I'm just like, all right, well, how do I find this again? Pandas APIs.types, pandas types. I have this, like, I don't know why. Every time I see pandas, I pronounce it as like pandas or pandas. When it's like, why don't you just say pandas? Like the bear. Yeah, I don't know why. I think like someone initially when I was learning this, like they pronounced it as pandas, and then it just like stuck with me. But it's just pandas, like the bear. So we can make this string or object actually. So let's just say object. And then cleaned horsepower equals cleaned horsepower dot as type. And this should be, let's say float 64. I think they're just integers, but you never know. So then if we do cleaned dot describe, this should tell us that there's now like numerical stuff. Actually, sorry, this should be info. So MPG is a float, cylinders as an object, displacement, horsepower. Yep, cool. Yeah, the two object classes are the now cylinders, which is going to be, can be converted to categorical, which I think I would rather do that. But I think that would be with scikit-learn. And then name is obviously string. So those are objects. Yeah. So now that we've changed those over, we can do plots of all the numeric functions. So let's just save and then cleaned.plot. And then the same thing, fig size equals something that's actually legible. Equals, so let's do 15, 10. And I forgot, we got to get rid of this because it's ugly. The little like random explainer text. Yeah, okay, so we've somehow got, well, I guess because displacement or the cylinders is still technically numerical, it's still plotting it here, but at least now we've got horsepower here finally. And they may all be on, oh no, they're not, they're all on the same scale. Yeah, this is not maybe the most informative plot because like cars are obviously very heavy, and then everything else is like not that high a number. So yeah, let's see, if the variable plotted on the x-axis is qualitative, then box plots will automatically be produced by the plot function. As usual, a number of options can be specified in order to customize the plots. So here we have pandas, oops, box plot. So we want to do cleaned dot box plot column equals here we've got cylinders. None of index cylinders are in the columns. What? What? Okay, let's just get rid of this part. Oh, it's still doing this numerically. Okay, let's still make fig size something legible. Fig size equals yeah, so now it's not even plotting cylinders, which is weird. And it says we should be able to group by so I think what we're trying to do in what they said is basically we want to do by an array like of strings. So we cylinders. Yeah, okay, so hopefully this makes sense, and actually we should make this a little bit bigger. Do 2015. So what this is actually doing is it's fixing cylinders. So we have three, 4, 5, 6, 8 cylinder cars or engines, and then it's saying like, okay, well, this is what the acceleration. I guess it's a 0 to 60 time. It's saying like, oh, these are all the things that are different. This is partly the problem with how it was with here. This obviously you cannot make any sense as to what's going on in these 6 graphs because the scale is totally messed up and it's totally affected by the weight here. So if there's a way I could make these all have separate scales, I could probably do that, and that would be much more informative. But at least like this is like the box plot way. Like this is essentially, it said you can do group. This is by is like group by, so like those classes are all there. I kind of wonder if we could do name or origin. Oh, origin's a year. No, it's not. Origin is a country code. Okay. Yeah, and I would say we could do name, but then that would just result in a crap ton of box plots for like no reason, because like there aren't that many car names, I think, in this data, and they're going back a long way. So like the Ford Pinto is obviously discontinued. So like to have multiple variations of the Pinto for like group bys is like really not helpful. You just have like all these plots again for like two categories. Yeah. Okay. So we can also try to make a histogram here. We can also make histograms with, I think it's, let me see, hist. Dataframe.hist. Yep. Dataframe.hist. So that would be cleaned.hist. We probably also want to do by because we need some sort of, how did they do it? By MPG. Dope. And should have done fig size equals 2015. This semicolon suppresses this like really horrific, oh boy, this really horrific text that just tells you that like, oh, you just made a bunch of subplots. Yeah. And pairs makes a scatter plot. Interesting. So plot.scatter. Wow, that's not a useful histogram. I don't know why they did this as a group by. That's kind of a mess. You can't read that. Okay, we'll just make this markdown. You can also use the dataframe.plot.scatter function to make scatter plots. So cleaned dot plot dot scatter, probably the same thing. Fig size equals let's say 1510. See how that looks. I forgot to turn that into code. Run this again. Oh, okay. So we need X and Y for a scatter plot. Um, that's interesting. So why would I'm surprised by this. It makes a scatter plot for every pair of variables. So you have to uh, from 9 choose 2. So that is a lot of plots. I don't really think that is totally useful or helpful. Um, okay, so instead of this, I'm actually just going to put help pd.dataframe.scatter and have that output. Oh, sorry, plot.scatter, and just display the help, because like it's just like here with this histogram plot. I like this is dumb. I don't know why. Like just because you can make a histogram from this many categories by grouping by miles per gallon doesn't mean it's a good idea, right? Like if anything, I would have just said like, oh, just do this again, but with make a series of histograms, but with the cylinders, because like I don't know, that's probably a lot more useful. In fact, let's copy the cell, and then insert a cell above. And we'll just paste. There we go. And then we're going to do cylinders. See, there's only 5. Like you can actually read this one, although it's still not particularly helpful. So for 3, 5, like, and there's no legend, so that's not great. But at least like you can somewhat see something. Here you just can't see anything at all. Yeah. That was weird. Okay, so in conjunction with the plot function, identify provides a useful interactive method for identifying the value of a particular variable for points on a plot. We pass in 3 arguments to identify: the x-axis variable, the y-axis variable, and the variable whose values we would like to see printed for each point. Then clicking one or more points in the plot and hitting escape will cause R to print the values of the variable of interest. The numbers printed under the identify function correspond to rows for selected points. That's actually, honestly, like pretty useful. So I don't know if there's a equivalent. Matplotlib identify points. I'm not aware of any plotting method which takes arrays or lists, but you use annotate. Oh, that's cool. A lot of formatting options for annotate, but it's not quite like, that's really cool. It's not like this. You can't click. You can't click and interact just like with the, at least with Matplotlib. That is a nice thing. I am honestly jealous of that one. So I'll just put in here, as far as I know, there is no Matplotlib equivalent to R's identify function to click / interact with individual points on a plot. For interactive plots, this may need something like Plotly, I believe is what it's called, for interactive capability. Python interactive plots. Yeah, it's Plotly. And we can just put this here. Okay. However, we do have like something like the summary function for data frames. Um, uh, you can use the describe function to display summary statistics for numerical data. So let's convert this to code. Oops. So it's shortcut Y. Okay. So it's help pd.dataframe.describe. So for example, if we wanted to do cleaned.describe, no big deal. There you go. So yeah, it gives you a bunch. On the categorical kinds, obviously it is not showing that. So let me put that. Unlike with R's summary function, categorical object qualitative, I'll just say qualitative, qualitative columns will not be included in describe results. For those, you can use something like value counts. So, dang it, I already forgot the cleaned cylinders dot value counts, and similarly cleaned name dot value counts. Yeah. And also, if you really want to, you can just pick now remembered how to convert a cell to markdown. You just hit M. You can also use the summary, not summary, describe function on individual variables. So let's say MPG, just like they did. So describe. Hey, so easy. Yeah, okay. Once we've finished using R, we type Q in order to shut it down or quit. When exiting R, we have the option to save the current workspace so that all objects, such as datasets, that we have created in this R session will be available next time. Before exiting R, we may want to save a record of all of the commands that we typed in the most recent session. This can be accomplished by using the save history function. And then next time we use R, we can load that history using the load history function if we wish. So it's going to be very different because this is done in a Jupyter notebook. With a Jupyter notebook like this one, all of the commands, all the variables and commands will clear once the once the kernel is shut down. Which is generally, depending on how you are working with the notebook, this can occur when the file is closed or when the kernel is shut down. Either by closing the kernel directly, closing or restarting the kernel directly, or shutting down the server, the Jupyter server. However, when written, not linearly, I'd say correctly, or sorry, not correctly, I'd say linearly, with all steps and executions in order, one can do a run all, execute all command to run all code cells from top to bottom, as long as random seed is set. The results should be the same every time. Okay. Okay. Yeah. So this is going to be notes and stuff. And I wonder where's the best place to put this, especially given that there is an applied section, which will obviously need code in a computer to run. So I'm going to close this cell, and I'm going to, oops, I think I'll just start like separate markdown things. Because this is still part of the lab, I believe. Lab. Oh no, it's not. Okay, these are just the exercises. Okay, so I'm gonna close this out, and that actually means that technically this lab is done. So what I'm going to do is I'm going to make a new notebook file, and I think I'm gonna rename this Chapter 2 Intro to, what would I rename this thing? I'll just do chapter 2.1. And then I'll create a new one that's C 2.2. This would be exercises. Oh, I need to make this a .ipynb. Okay, cool. And then I'll copy all this stuff over so that it's like section 2.4. Yeah. Why don't I just start that now, actually? Okay. Oh, what did I do? There we go. Okay. 2.4. And this is exercises. This notebook file is intended to be a solution set with translation of the R exercises, R code, solution set of the exercises with translation of the R code included in chapter 2. So this is a part that I guess I'll have to figure out how to do, because while I would like to contribute this back to open source, it's probably not all that helpful if the solutions are just included. So I might have to like write out the stuff and then make sure everything works okay, and then make a separate branch that's like chapter 2 solutions, and I'll just put that up on GitHub. So yeah, cool. All right, I think that means I've been streaming for over 2 hours, and it's 6:30. Yeah, 2 hours, 6 minutes. Okay, so that was work. So it was interesting to kind of like try to translate live these R functions into Python. Yeah, I can definitely see why they didn't want to do that. So I'm really excited to you know what? I'm actually noticing, does it make sense to call it 2.1 when it's actually section 2.3 and section 2.4? That's mm, that's hard, right? Because like if I were to label this as 2.3 and then the next is 2.4, it might cause confusion as to where the like 2.1 and 2.2 are. But maybe it'll change in the future where like there's just going to be as part of like uh, maybe I will like write notes and stuff. Well, that's my personal notes, you know? Okay, so actually, I'm just going to rename this and just maybe save some teething pains for later and just call these 2 point what their actual sections are. Um, okay, cool. Cool, cool, cool. All right. I am going to now, so let's look at our Git status. So we're going to CD into notebook because otherwise I'm going to have to type notebooks every single time. So git add C2 intro, oh darn, C2, there we go, and then C2.3 and C2.4, and autocomplete is so helpful because I never remember what is like, oh, what is the escape key so it can incorporate spaces and special characters. So if we look at our Git status now, everything seems fine. So we're going to commit. VS Code will open up. We get to add a new commit message. So it's we finish the chapter 2 lab, create file for C2 exercises. And it's going to run over. So we're just going to save a bunch of characters. Whoop. Okay. C2 lab, create file for C2 exercises. So we'll say finished walkthrough of C2, of translating chapter 2 lab from R to Python functions via Numpy, SciPy, and pandas. Oh look, the word wrap didn't work. Okay, let's try to fix this. Word wrap. Still didn't work. Word wrap. Well, okay. It's not totally working. I don't know if it's super necessary for me to fix this. Okay, let's try to fix it. Otherwise, I'm gonna go crazy. Git VS Code word wrap not working. The new command from the view menu, toggle word wrap. View. Okay, well, it's on there. Settings, word wrap column, bounded. So if we, oops. Okay, well, that's certainly better than before. I don't even know if, let's see if we, I think it will just fix that by, oh, okay, well, yeah, it's hard to complain about that one. Oh, that was weird. Terminal's just like hung. Word wrap, git. How to enable, disable, advanced. I think that means I have to actually set this. Editor word wrap. Okay, so let's editor.word wrap column. Yeah, let's do 72. And then I think similarly here, editor.wordwrap.column, and then we'll actually make this 120 to match the other thing. Maybe it'll work on the next time I bring this up. Did not complete subarray indexing section with Numpy because it is not clear if this is a worthwhile thing to translate over. And quick searches didn't seem to find easy replacements, parallels to R. To do exercise section 2.4 exercises. One, write out problem statements. Two, make translations for the R sections. Three, create new branch for solutions. Actually, three, push to Git, and four, create new branch for solutions. 5, push chapter to exercise solutions branch Git, but do not merge. Directly to main. Maybe consider rolling with a solutions, overall solutions branch that parallels main. Okay, cool. That is probably fine. So I'll close this. Let's see. Or word wrap. Oh, I think I have to put. I think I have to convert this to word wrap column, right? Instead of on. And I think I want actually the same thing here. And yeah, okay. All right, so git status, everything should be committed now. Yeah, git push origin chapter 2 lab. All the files are going up. And yeah, with it pushed, I can do a merge on GitHub. And let me see. GitHub, intro to stat learning. Oh, look at that. There's a pull request. So let's merge this in here. Obviously, I don't think there are any problems. It's going to be interesting to have the solutions branch separate. Yeah, okay. So I think that is probably what I'm going to do. I'll make like a general solutions branch that is in parallel with main. And then keep adding little sub branches that merge into the solutions branch. Whew, what a long sit period. Okay, so I'm gonna git switch back into main, git pull origin main. Okay, cool. And that means that we should be totally up to date. Yeah. Okay. Cool. All right. So I think that means it is a good time to stop. Past a good time to stop. I'm sorry you're seeing my OBS again. But yeah. I was gonna say had fun. Not really. I think you saw that when I was trying to translate some of that sub-indexing. But I'm glad that I went through this because it was good to kind of work through everything. And I'm excited to actually keep going with this chapter and go through the exercises and stuff. So yeah, if you see this obviously later, you can feel free to message me. I'm curious what you're working on and what you're trying to learn. And hopefully, if you're curious about trying to take this Intro to Stat Learning and work through this textbook, which is really, really helpful, honestly. Like, there is a more elaborate version, the Elements of Statistical Learning, that has a lot of math derivations, but like to understand what you're, like the overall theory behind it, it's nice that it like abstracts away some of those calculations. The other Elements is like a text, like a reference, not like a thing you can, well, if you want to, you can, but I found it was like a little too dense for me, especially in like, say, practicing for interviews. So yeah. I am looking forward to next time, at least on Tuesday. Who knows? I'll probably just come on and keep working through this. But yeah, until then, I hope you have a great day, great evening, great night. I have no idea where you are. And looking forward to seeing you again. All right. Good night. Bye.